In recent years, AI has really just blown up. With the development of deep neural networks, we've been able to achieve far and beyond what we've ever been before. Now, from simple tasks such as image classification and natural language processing to more advanced complex things such as self-driving cars and AI-generated artworks, AI has just been able to exponentially grow. And with this, we've naturally become a little bit more dependent on AI. And while this may have its own set of benefits, it also has its own set of downfalls. And today, one of those downfalls I'm going to be focusing on is something called a generative attack. Now, a generative attack is essentially when noise is added to the input of a neural network so that the neural network produces a wrong output. Now, let's take this as an example. Let's say I'm sitting in a self-driving car. My self-driving car approaches a stop sign, but unbeknownst to me, the stop sign has a small sticker attached to it that I can't see, but the self-driving car can recognize. Now, when this happens, the self-driving car misclassifies my stop sign as just something entirely different. And as such, it just speeds straight up, it doesn't stop. And this in turn creates a major traffic collision. So that's just one of the examples of the disastrous implications of something like a generative attack. And they can vary in scale, but it can get a lot worse than just that. And the worst part is, generative attacks, they're effective and they're also relatively simple to make. It's very hard to defend against them, and at this point, it's much easier to create one than to reject one. So how it works is normally in a neural network, we have a loss function that tells us how good an output was. So for example, let's say that I have an input image in an image classifier of a dog. This dog is passed through my neural network and is sent through a bunch of classes. Now, my expected output is going to be a dog class because it's an image classifier. I should recognize a dog as a dog. But let's say my neural network outputs instead a cat. Now, my loss function will basically tell my neural network that this is a bad input, and it will tell it to reiterate until it can get to the right input. So, generative attacks exploit a loss function. So they basically customize the loss function for an incorrect expected output. So going with the same example of an image classifier, let's say I have a dog, again, as my input image. But my loss function is customized so that my expected output is no longer the dog, but rather, for example, a frog. Now in this case, my neural network will only think that it's predicted a good output if I predict a frog. Now I can't actually adjust the weights of my neural network, so instead I'm just going to add noise that I can change, so tunable noise, to my input image, and I'll just keep adjusting that noise until I can eventually minimize the loss function for this incorrect expected output. And if I do this iteratively, I will eventually get an image that my neural network recognizes as a frog, even though I might see it as a dog. Now, I've actually made my own generative attack by creating my own fake image. And while this might not be as high quality as some other images, with more training it can be. But you notice on the left and the right, the images are relatively similar. But the image on the left is actually misclassified as a frog. Now, point being here is that generative attacks, they're very easy to make and they're very powerful. Because just with a little bit more tuning, the image on the left may be completely indistinguishable to the human eye compared to the image on the right. Now, the point of this video is really just this. AI is powerful, and while we may want to depend on it, we also need to be very careful about what it might do in terms of harm if it goes out of hand. So that's why until we really develop a generative defense that can basically counteract against all forms of generative attack, we really need to be careful in where we're using our neural networks, and we need to be careful in letting it make our decisions for us. Thank you for listening.